5A, fundamentals of statistics. We often see numbers, data presented in a way to pass information on to us. Statistics is the science of collecting, organizing, interpreting these data. But we also use the word statistics to represent these values and information that is used to summarize the result. Here, we're going to look at the survey from 2020 on how the Canadian women feel about their financial security. Around 62% of Canadian women feels that they worry about their finance. In the survey example that we just talked about, the population is the set of people that we're trying to study. In this particular case, we are trying to study Canadian women. The sample is the subset, is the people that we selected to actually ask the questions for the survey. We cannot go and ask every single Canadian woman and ask them to answer these questions for us. But what we can do is we can pick a small number of the population, the sample, to answer these questions. In this particular example, if you look at the detail of this survey, 3,000 randomly, around 3,035 randomly selected Canadian women answered the survey, and they formed the sample of this study. Population parameters are the numbers of interest that we use to describe the population. In this case, we are talking about the percentage of Canadian women who feels like they are concerned about their finance. So it's actually the number associated with it, population parameter. And sample statistic is the number describing the sample and how the sample sort of answered the characteristic. So in this case, we have 62% of our sample. They answered that they worry about their finance on the survey, and that is our sample statistics. 62% of the Canadian women feel concerned about their finance. When we do a statistical study, what we want to do is first identify the population, right? Who do we want to study, and what would we like to learn from them? And from the population, we would choose a sample. We can't go and study every single person or ask questions to every single person. What we have to do is we have to pick a few of them to make up our sample and do the test or ask the questions. From our sample, we're going to gather data, and we're going to get some information from the sample, and we call them sample statistics. And using these sample statistics, we can answer something about the population. We can say that, if our sample has 62% of the women feeling concerned about their finance, well, for our population, for all Canadian women, we will have somewhere around the same amount of women, Canadian women, that feel concerned about their finance. And that's sort of how we arrive at the population parameter and draw our conclusion. One of the important things is to choose a representative sample. We had to choose a sample that will give us similar answer to the population. In the survey that we use as an example, 62% of the women worry about their finance. So we can say approximately 62% of Canadian women feels worry about their finance. But that is only if we chose our sample correctly. There are different sampling methods that we use. One is called convenience sampling. We just ask whoever will answer the question for us. For example, if you listen to the radio and the radio host asks some question and people call into the radio to answer, or if you have a Twitter account, if there's a Twitter poll and people who answer the Twitter poll for you, these are called convenience sampling. Whoever comes and answers the question for you. Sometimes that's not a very good way to answer to do our sampling. If I hand out a questionnaire, usually people who would be willing to spend the time to write answers down for you usually feel really strongly one way or the other. If for people who feel neutral, a lot of times they don't bother answering the question or participate in the study for you. So what we'll want to do is we'll want to do different ways to sort of minimize that. One of the ways that we can do is called simple random sampling. That means we pick a whole bunch of everyone in the population, every single item in the population has equal chance of being selected. We can also do systematic sampling. We go to our population and we have some sort of ways to pick sample systematically. We can select, for example, every 10th member. We can select everyone whose social security number or social insurance number ends with a certain digit. We can also do cluster sampling. Cluster sampling means we divide the population into groups first and then select a few of these groups. These are called cluster sampling. And finally, we have stratified sampling. Sometimes our population have different groups, whether it's groups of different race, groups of different gender, groups of different age. What we want is we might want to make sure that we select people who belong to these groups, belongs to the different groups, and every single group is covered proportionally. So what we'll do is we'll divide the population up into these groups, then we'll draw a simple random sample from each subgroup, and usually these sample that we build up in it eventually, each of the subgroup has the sample that we pick from each of the subgroup has the correct proportion as to how the subgroup makes up the whole population. Let's go through some examples. Let's say we have a list of all the homeowners. If we draw 150 of them to survey, then what kind of sampling is this? This is, of course, an example of simple random sampling. Let's say I walk down the hallway and talk to every 10th person that I meet. This is systematic sampling. Let's say we are doing a survey and we are just talking to every student who are in section taught by Charles. And because we are sort of grouping the students in the school into different sections of courses that they are taking, and we're selecting a few different sections, This is called cluster sampling. Perhaps we want to check residue of a pesticide on apples. And we have different apple farms. We want to make sure each of the apple farms are checked. So we might go to each of the 104 apple farms, and we pick a few apples from each of them. This is called stratified sampling. We go to each farm, we separate the apples according to which farm they come from, and we select a few apples from each farm. When we do statistical studies, there are two basic types of statistical studies. One is called an observational study. We just look and do measurements. Sometimes it might be a survey. People answer questions for us. But we do not try to change any of these characteristics. In an experiment, what we'll do is we'll apply some sort of treatment or apply some sort of change, and then we look at what the result is, and then we do our observation later on. But notice the opinion pool that we talk about, the example of the survey, that's an observational study. For example, if I try to sort of find out what's the average weight of, say, students in our college, what we'll do is we'll go and do measurements, but our measurement doesn't actually make people gain or lose weight. So this is also an observational study. If we do a medical study, most of the medical studies are done as an experiment. We want to test whether a certain medicine or a certain substance, vitamin C, can help us prevent cold. In this case, we have to give the vitamin C to our participants, to our sample, and then we measure them after. So this is an experiment when we're doing change. Here we have two different groups in an experiment. Typically, we will need to have a treatment group and a control group. If you give the same treatment, let's say you give vitamin C to everyone, and they improve, you actually have no idea what you mean by improving is, right? What are you comparing it to? So typically, we will need to have two groups, and the group that got vitamin C is compared with the group that did not get vitamin C, so that I can compare, well, what happened? Did one group do better than the other group? But because when we have an experiment involving people, we can have biases. We can have biases because these people that's in our experiment, they know it's an experiment, and they sort of have expectation built up due to the treatment that we give them. A typical example is called a placebo, the placebo effect. So what happens is this: if you go to the doctor and the doctor tell you to go home and get rest because you have a cold, if we compare that with the doctor giving you sugar pills, well, sugar pill feels like a stronger intervention, a stronger treatment. And even though it's a sugar pill that doesn't help us recover from our cold or from our sickness, we will feel that the doctor gave us drugs, and so we should feel better. And study has shown that people feel better when they receive fake pills. In fact, people will feel a lot better if they get an even stronger injection, say salt water. The doctor gives them an injection That seems like an even stronger treatment of salt water. So they got injected salt water by the doctor. The sample, people in the sample will feel like, wow, I get a really strong treatment, and I should feel better faster. My recovery should be faster, and that's what happened. That's what happened in the placebo effect. People have some belief. People have some belief with that corresponds to the treatment that they receive. And a lot of times, these beliefs will help them improve or change their condition. So what we'll have to do when we apply treatment to both the treatment group and the control group, we have to make sure, even though the control group doesn't get the treatment, they have to get something similar to the treatment. So if we're testing to see how vitamin C can prevent cold, then the two groups of people must receive some sort of pills. One group will receive vitamin C, the treatment group will receive vitamin C, and the control group will receive a placebo, will receive sugar pills. When we test the efficacy, the usefulness of, say, COVID vaccines, the two groups needs to receive an injection. They both need to receive an injection. In the treatment group, they receive the real vaccine. In the control group, they receive the placebo. They usually just receive sugar water in a shot. And for people participate in the experiment, they have no idea whether they are in the treatment group and receive the real vaccine, or whether they are in the control group that received the fake shot. This practice of keeping people in the dark about the treatment group and who's in the control group, this is called anonymizing. When we have the participants, people in the sample, not knowing whether they're in the treatment group or control group, this is called single anonymous. Sometimes the experiment needs to be double anonymous because let's say a drug company is trying to make a new COVID vaccine. Because making a new COVID vaccine could be very profitable. It is very important for the drug company to be successful, having a good COVID vaccine that they develop. So people who give the treatment and people who do the observation, so the doctors who do the observation and see how many people get sick and how many of these cases are very serious, if they are hired by the drug company, then there's an incentive. There's an incentive. It is beneficial for these doctors to say that, oh, people in the treatment group are not having serious COVID, have lower amount of COVID cases, so that the vaccine works, and the drug company can take the vaccine to the market and make a whole bunch of money because they are employed by the drug company. So it is important for the people doing the treatment and doing the measurement to not know which group the sample belongs to, whether people belongs to the treatment group or the control group. In this situation, if the participant doesn't know and the experiment doesn't know which group these participant belongs to, this is called double anonymous. There are experiments where it's not practical or unethical to actually do one. For example, we could want to study how alcohol consumed during pregnancy affect newborns. And our hypothesis, we might be guessing that alcohol during pregnancy could cause deformity, could cause mental illness to these babies. In this case, it would not be a good thing to get a whole bunch of mothers who are pregnant with babies and have half of them drink a lot of alcohol and have half of them drink something else. If we force this type of experiment on moms, then if it actually has a negative impact on these newborn babies, then we would be harming these newborn babies by force feeding them alcohol in our experiment. So what we can only do is we can only study cases where mothers drink alcohol during pregnancy themselves by choice. They decided themselves, and we compare it to mothers who did not drink alcohol during pregnancy. And we are doing observation, and by separating these cases into two groups, these past cases into two groups, it's almost like doing an experiment. And we do these type of study, we call these type of study retrospective studies. Finally, when we have our sample statistics and we want to apply the values that we got to the population parameter, we need to consider the error. For example, let's say 62% of the women surveyed worry about their finance. Well, in the real population, in all Canadian women, it's not going to be exactly 62%. But we can do an estimate. The margin of error is how good our estimation is. In this case, because the margin of error is 1.6, that tells me that we are more or less certain, we are confident that all Canadian women in the population, a lot of them will worry about their finance. How much? Somewhere between 60.4, 62 minus my margin of error, all the way up to 62 plus my margin of error, 63.6%. And we call this the confidence interval. We know that Canadian women who worry about their finance, the proportion of Canadian women that worries about their finance is somewhere between 60.4 to 63.6%.